All right. Okay. We are live. Okay. So hi everybody. My name is Daniel Escobar from Diffusion Architecture. Today we are joined by Daniel Koehler. He's an urbanist, architect, and assistant professor for architecture computation at UT Austin. Before Daniel researched at the Bartlett in London and Innsbruck University, where he wrote his Ph.D., published as Mereological City, a study on the power relationships in the modern period. Daniel's work has been exhibited in Prague, Milan, Venice, Montreal, London, Berlin, Austin, and is part of the permanent collection of the Centre Pompidou in Paris. His current research focuses on the implications of artificial intelligence on the design practice of cities and their architecture. And today we'll be talking about into large language models, recent publications in research in architecture and AI, and also exploring the concept of zero-mile architecture and how large language models reshape our world, shifting from text to language. So to get started, Daniel Koehler, thank you for joining us. And it's a pleasure to have you here. He will start with a 10-minute presentation of his work, and then we'll do a live conversation, more in-depth topics, and a little bit of his background. So the floor is yours, Daniel. Thank you.
Okay, thanks for the invitation, Daniel. I bet this will be architecture 10 minutes presentation, so it can be a bit longer. Let's say I tried a bit like to prepare a statement more. So what I mean with zero-mile architecture, I think that large language models, because of their contextual relations, in a way collapse all distance into very close proximity, so like into like everything into one object. Why this would be beneficial? So this is a map based on a synthetic data set, mapping out carbon emissions embodied in existing buildings. So going forward, from 2030 on, if you want to keep Paris Agreement, actually this map should be actually white, so that not any building anymore contains a new building would in a way emit new carbon. Further challenge, so far we built it like a, even can't pronounce this number, amount of material we built, but by seeing like population growth and also like economic growth, or like kind of like demand on like building more space for more people, is actually we have predictions that to 2050 we will in a way double that environment. Livable space decreases by population increases, which means we have actually anything what we have to do, we have somehow to arrange on 1 acre, which might look like that. We might find, or we need to find, with depleted resources, ways, for example, to 3D print from anything, anywhere, or using recycled materials, which can be anything. So this seems like a challenge, like which is nearly like impossible to accept, impossible to think in a way how to implement. But I think that purely like looking on the technological advancements, or what comes with the idea of starting maybe 15, 20 years ago with the idea of big data, which led now like to large language models, and will continue with large action models, or whatever new names you find, with kind of amount of increasing complexity. I think we now shifted in a new kind of, or phase shifted, you could say, also with kind of architectural concepts into a realm that would allow actually to build such a complexity, where you could like build anything, anywhere, from anything, in a way. So let's look like to, in a way, like digital architecture or parametric you could also say that's early research from William Mitchell, like which shows that you, by defining like set of rules, you can vary the properties, attributes of a single object in a predefined context. So you could say like we work with a term, a word, or like a set of understandings to a specific item or object, and begin to relate this in a text. You can see is also critical or demand from that's like a criticism in architecture, like Peter Eisenman did, that you demand that like in a way like the placement of this terms or objects in a context should in a way like distant that object or this term, like not leading from, by implementing it in a context, you lead to certain complexity or exceeding complexity to kind of range of strange objects and so on. But again, you work with a predefined set of a term and begin to articulate or trying to exceed that articulation. When we begin to move in machine learning, and this is like the groundbreaking work by Stanislav Chalu, for example, who takes GANs and now like takes also like specific understanding of a concept or like a paradigm, how it could learn certain features in a context. And in that bounded context, begins to, in a way, like the GAN or the machine learning model begins to understand how to act within that bounded context. That all leads always like, we can very much like in very complex understanding the bounded context, as soon like you have again like that kind of bounding in a context, you can again like implement this into that. But in reality, what this kind of like to this moment, digital architecture led actually that mostly you don't have a context yet. Mostly like digital architecture is not like, is more like unfolded as this kind of types, where like because of like an inherent description or like a limited form of descriptions of like how you understand or hear a set of apartments and how those could be traded in a way on already global markets, led actually to demand that like you don't vary them, but like you see them in the kind of like standard kind of form of variation or this bound, which led in a way exactly to the opposite what variation should lead to. But I think like when you look what actually large language models produce by making the step from working with text to languages, actually, you see that you now like you begin to compress in a way whole context or generate buildings from its context. So it's not anymore that you look to the definition and the bounding of one term and how you can declinate between those bounds, but in a way it's like injecting something into a certain condition from a way having a language first and then moving in a way into that specific kind of the point in a latent space. So we move to architecture as language, like opposed to like a kind of like syntactical kind of operation, like by looking how an object is like oriented between a difference of objects. So it's fundamental difference. Of course, it is a notion of type topology revives to that. So why those models do this? Of course, they're trained always fundamental that any kind of data is always contextual. Like when you make a photo from a house, like when it's ever like without vegetation or like trees. So it's obvious that when you generate an image of a building, that most likely it will also have artifacts of trees and plants. But I can do this like they're more hyperdimensional, this context. So of course, like when I'm here, I'm using just a simple outpainting model that kind of features, or these are grottos, that they also resonate with kind of learned contexts which are not in a close neighborhood of our like human understanding of like what that context might be. And I think that is crucial. That's kind of at first like non-human centered context, but also like context that again, like they're defined as language. So like beginning from anything, what could be in that body of data, defining it at first, like spanning it as context, and then like compressing it. You lead to relation and to first like artifacts more. That completely embed something beyond our like expectations. What in a way anything related to building like might be. When you prompt, for example, just simply city names, you get like quite often quite weird creatures instead of like a panorama of a city. Of course, like city names are like also like inherent all those narratives, myths, and mythologies cities are historical built on. I can do this also now because they embed context. I can do this also now more rational. For example, pushing work which is fundamentally 2D, like two-dimensional artists, pushing them in the three-dimensional realm. And we see this also that further training or like how actually it would generate 3D context. This is now development of the new models. You don't do actually 3D from really training something in the 3D realm, but you in a way like begin to move from the context of or the data which you have in 1D to 2D to 3D and so on. So you begin to build up from those contextual complexity, you can build up and now derive like further kind of coherences between them. Is an architecture interesting? When I now take, for example, a material, I can scale this up and directly when I prompt with materials, I have forms of constructions already embedded. So what is if I'm continuing with that and not only have forms of constructions, but forms of actions? Like how does actually climate sink looks like when I'm taking hay for climate sinking? So it allows us like, no, like to have like a highly augmented sensibility by directly not changing actually by very rough like design features operating on them as a human, but actually operating with a highly intricate kind of sensibility of a material nature like grotesque context. I can do this with geologies. I can do this with trees. Do you know like which tree is actually in which location? I can move a tree actually full context now. And I can map this out. Where like these models begin to understand very, very much like geolocations or like context in space. But they also understand like complex relations. For example, there's like prompting a canopy in different cities. But of course, in some cities, when I'm having cities more in northern sphere with snow loads, canopy from a textile doesn't make sense. So it generates me a glass roof or a textile below a glass roof, for example. So there's an completely embodied intelligence with that, which like I would never think even to embody. The resolution, of course, it goes completely on the interiority. So now I can read cities and describe cities through their complete interiority. I can move in a way, like through the world, or I'm here moving in a way through a corridor, through in a way like 6,000 cities, worldwide cities, and in a way looking for their continuities. And again, I can map this out in a world map in this kind of like geography of data. This map doesn't look like a Mercator projection because it takes most cities on a comfort zone of the 20-40 degree zone. And it's now like it begins to arrange or like I have a simple script which arranged those images or like that there is a bit distorted, but I think you can a bit like have some resemblance of continents. So what I did the last few months was actually now mapping out in a way the world within or the world of architecture within actually those large models. So here that's now a database which I have soon or will soon bring live or share this soon, which in a way like has over 100 different samples from 6,000 cities. So it's a database of 600,000 images roughly on in a way like different locations worldwide. You see already like how understanding from architecture or cities can change when you have those kind of like instant access, very comparable to any place. How like yeah, like how relative actually places become, and on a kind of level of intimacy also. So the similarity when I map like or can now use those models, of course, as a mathematical model, so I can print out or like map out the similarities between them. Uh, I can do this like it's very rigid, very brutal. I can map different complexities, and I can go, of course, like what I showed like in the beginning, the kind of measuring of embodied carbon for that. But I don't think, or like this is just like case studies from research where I try like to make sense or like begin to measure those. But I think it's more like going on the word of the kind of there's something in the collaboration with those models when you embed or inject yourself like with a kind of word of creativity and narratives and really begin to map out now what is kind of like close proximity and access to anything anywhere actually to what it would be helpful for you. Like here, not speculating on kind of reversal, for example, streets as buildings when you don't need so much street space anymore. How far you can go with organic materials and building dense environments. How you begin to reuse kind of car infrastructure. But then it gets interesting, just the ordinary condition how those models actually generate. This is kind of like extreme proximity or really like collapsing of places into each other. It's like really like a zero distance you have now between in a way like exterior interior. There's no any kind of chance of kind of notions of privacy, notions of somehow anything like materiality, construction, anything like becomes in a way in a singular moment or collapses into that. And I think, but still, like that we can learn. I think we should or look carefully to such images. Like there's a lot of like critique that those geometrical doesn't make sense. But when parametricism started, did curves or building from curves, did it make sense? Did NURBS geometry even exist? Could we actually build that? So why we not learn from those kind of like really like the speculation from the speculation, that the inherent kind of geometries of those models, and push them towards like to help in a way like environmentally to yeah like change the way how we think and build architecture. So it would be from my side a statement.
Okay, awesome. Thank
Awesome.
you for that.
Thank you for that. So let me stop that. Okay.
Yeah.
Yeah.
I got an echo. Give me a Okay. Hello?
Yeah.
Okay, cool. Yeah, so that was really interesting, and I think let's go back a little bit because this kind of like brings up like a really interesting topic of how these large language models or pre-trained models with like whatever imagery exists on the internet, and how they were trained, like how that is capturing some sort of statistic correlations between their location and context, and how we can apply that to generate like kind of like an overall understanding or some sort of like unsupervised understanding in some way of like the how these buildings are being seen through the lenses of images that live on the internet. Can you maybe talk a little bit about, I guess, like how do you see the understanding of these models evolving, or like is there like you're taking them as a generative model, but how do you see them, for example, as like a useful representation? Or is it something that you do see like statistical correlations? And I think one of your papers, you kind of mentioned that there might be some limitations to how they represent in these cities. So maybe talk a little bit about like those representations.
Yeah, like we're now like 2 years something ish into like with the large scale diffusion models, but
Hmm.
not like let's say stable diffusion 1.5. Um, yeah, so of course I would assume that larger sets will always like increase. At the moment, or the stable diffusion family, it's so far what's publicly available, like this information are trained on the Lion data set with 5 billion images,
Hmm.
which is actually not much when you think about that you have 10 to 20,000 images on your phone. So it somehow relates to a kind of collective knowledge of then roughly, let's say, 500, 400,000 people. So like a mid-sized city, but not like a world population. So there's a difference with the image models, like to the text models, that for the few terabyte on text is yeah, it's like I think a few millions or billions books, or like this is kind of one say that you need somehow like 2 million years to read for such
Hmm.
data if you would say it out. Whereas, yeah, like it's with images, it's much different. So actually, they're at the moment like still on a very limited set of data, which I would predict like if you're more reasonable, collect this data, you can in a way also more detail, more correlate more information within that. You have algorithms from PyTorch or Meta and or like anyhow the involved uh, machine models. You have algorithms that can measure actually if certain clips or like no, if there are correlations between, for example, city names and that generated images. So you can measure that out. You can also simply like you can recognize bias. I didn't include this
Hmm.
now, but it's actually easy like also to train another model actually on a set and filter out in a way bias. Bias is mostly when a model doesn't know what to do, it makes some standard. It will always then generate like something what it wants as a main concept learned. So actually, when you have a data set where like a lot of images are quite similar, like you can quickly like just take them out because most likely they're actually biased. And so they have versions or that they have methods in a way to navigate through those data sets and also to leverage, hey, what is actually uh, in a way biased, what's not. And but for me, it's more interesting that it's actually it's not so much about a precise representation, but already about learned concepts, which goes back is much more for me like architectural is like a discourse or discussion then on permanence or like how a place in a way is perceived, but now also not like perceived as a from a cultural like a societal or social point of view, by like inner perception or like how people or as you would take a questionnaire, let's say how someone like a set or like a range of people like would understand certain places, but also like because it's like this hyperdimensional models, it means also this questionnaire would go into forms of constructions, into forms of vegetation, and so on. No? Like the same as this kind of perception is like also to kind of like non-human actors. But it's also even like very emergent because like it's even what in a way the attention to certain kind of concepts actually
Hmm.
is completely emergent. Or this models they learn this from scratch. So we even don't know what in a way what is in a way like an actor or like someone who perceives or like what that's like everything inherent as models. They have like is not only like mapping a latent space, but also like between like clusters of attention in this latent space, you, in a way, there's also correlations between this. This way, where currently like every researcher freaks out, like that we completely don't understand what's actually going on in those models. But I would argue that in itself, like these kind of learned concepts stay in a way like in like dialogue is the wrong word, in maybe like attraction or proximity to each other, and this in a way leads to ecology of concepts, which also like decide like on like correlated relevances. It's very abstract. I mean, like it's also like pure. A lot of that is pure speculation because you can't even visualize that. No, so.
Yeah, and I think what's is really interesting about these models is kind of like what you're talking about, like the scale of like the training data set. And one of the I guess like one of the things that came out recently is that what makes really interesting with like GPT-4 or like these large language models is like the amount of the tokens or like information that they have to ingest to be able to get these emergent properties in some way. So it's not so much like the architecture of the actual model plays a part, but it's just the amount of data, the data that would get these sort of properties or the emergent properties of context and relationships and so on. And I think one of the other things that you talked about in some of your research papers is the idea of like a synthetic data set for architecture, which this kind of, I think it's kind of fascinating to see where you're taking your research into like the cities, but then now how do we translate this into like a synthetic data set that might be actually useful to use generative models in architecture, right? And you speak about this a little bit of how we can go past certain limitations with a synthetic data set that might get us like a high resolution of architectural intelligence. So maybe talk a little bit about that and that type of work.
I mean, generally, like, architecture is always data poor. First, like
Yeah.
not any office shares data or like plans or something. Most are under disclosure. Also understandable, reasonable. Most concern is like most architectural representations at the moment are expert. I mean, like show. I mean, when you enter architecture studies, you need to learn what actually a plan is. Like you don't understand like ad hoc actually how to read a plan. And so I think like also the data which we would have in architecture is not really useful or comparable actually to the data which like not like aligns with the common data training data, which means like simply like or most likely like photos like from anything, like is the most simplest form of
Yeah.
representation is something like a photograph, no? I think like with a common lens, and this not as necessary to be like a social media kind of source, but photos is I think then the way of to go, no? Like a camera perception. So we need to find way to align in a way the knowledge with an architecture in a way then with images. But how we do this if we somehow we have a lot of images, but also not enough in a way to articulate what would be important. The same is now how you actually when you now train a model, so you need to find ways how to inject actually new models, new concepts. So you need in a way to generate also those concepts to inject them into those models. As you can then just actually do over synthetic data. So you could in a way how you would actually distribute new knowledge would be then in like injecting not only a prompt, but injecting in a way custom data. Now you see this in the text models, you see this already people are building like custom bots by in a way extending this with their own database. So here would synthetic data help a lot because you could now simulate new forms of construction or like materials which you simulate. and then in a way inject this as a custom body of data into like, build on those models. So you could do so. A classic way is the fine-tuning way of a fine-tuning model. So this would be the parallel thing to the custom training of text models in a way. Yeah.
And I think you made like a good point about Alberti, how he described in one of your articles about studying architecture after AI, which I thought was really interesting, where you said like Alberti's treatise did not contain any drawings, images, or other notations, but yet like as architects we have to kind of like understand all that. Um, and how do you think that we are, or we can encapsulate kind of like the architectural intelligence into like one of these models? Because I think the whole concept of like training large language models is that you got to tokenize everything, right? So you have to be able to, in a way, to put this, if you want to fine tune a model, uh, tokenize architectural knowledge in some way. And maybe you get some from text, but when we're dealing in 3D dimensions and there's some sort of like uh, specific knowledge or relationships that go into like the components of a building, right? Materiality, context, how the spaces are related to each other, like maybe some regulations. And to me, I think that's still like a very hard problem. And I think you kind of capture that a little bit in your text. But how do you see that? Do you see like some sort of solution to that? Like, is it something that's still evolving? Or how do we approach this as architect designers and computational designers?
I think we don't need 3D data. So I'm
Yeah.
they go a polemic position. When you look at the new video models, so they're
Mhm.
like very continuous, actually understand space already. And more so, it's like not only understand continuous space, they understand also how to continuously act and operate in that space, how to behave there. So when you think of robotics training, when you think of an assembly of a building or something, that's certainly the way to go. Though what those video models already prove is that that those models understand a consistency in behavior, procedures. So there's a relation with time and space already embedded in these models.
Mhm.
Uh, so and this is not only that you learn this from purely from video, like it's also like, or like the stable 1, 2, 3. So like you take text, you take the relation between text and images, and then from that you learn the correlation with a set of images. So I think there's a great way also like to build like comparable models actually for architecture. You don't describe actually building just with plans. There's also like there's like a whole set of different forms of notations we use today. With the Alberti argument, I mean, what Alberti like intentionally didn't use any drawings or so on because they would be ambiguous, and he wanted to save time in notating. So he like just like used text as a code. I mean, there's Mario Capo's argument with the comparison between alphabets or pure text and then algorithmic approaches. So for me, this goes more that, finally, as an architect, you actually, it's not so much about like how you notate. So maybe it's also, that's now something which is not anymore now at our hand, that we can control actually how you notate. When you see of the resources involved in data preparation and as training, so which is really, you need just a large corporation. If this, I hope there will be a non-profit way. I hope that we get financing for open source models much more. I think we need that. But it's clear that maybe it will not even come from an architecture field specific point. So same as those models are now highly contextual, multidimensionally, and so on. So maybe it also suggests that we have to work also much more like outside viewing, like architects for architects, or like that you describe inherent, like, that you say like, hey, our discipline is like the way how we describe or this notate, and this way how we do the maybe it's been more like how you, I think to notate would be more how you actually navigate through those models. So you need very clear like formal strategies, how you actually compose or like get actually in relevant results, or like certain kind of prompt engineering suitable for architecture. Like more, I think in this way it goes like the relevance of looking or working with large models. So I can, or like when you look also to resources which it takes to train those models. So
Yeah.
I don't think that's even anymore in the scope from architects, which is also a good thing, because it means like from different fields already, like experts in a way, or other kind of institutions, agencies, define already what would be relevant for making a building. That's actually sounds much more scientific in a way. No? It's
Mhm.
sounds also much more promising when we need actually to take such amount of effort actually for reinventing how we actually build, from which materials. I mean, like we cannot put everything on our shoulders. So it's actually like going actually off in the thinking how we should actually train those models, to more how we begin actually meaningful to use them, or then again like to link actually to other experts or our fields.
Mhm.
That I think could be also a way to go. So how you like offer like I don't know, material studies to chemists, or how you really like uh, communicate that like a certain material would be now relevant for at the scale of a building. I mean, you will not cook it up by yourself. You can maybe generate that, but you need, like completely different fields now to actually to develop those materials than reality. So I think they offer also new forms of communication, and maybe like it's also a pathway, a much more realistic pathway to go, that we listen more. How we could actually, what forms of notations are in a way coming with those models, now how we communicate
Mhm.
with our experts in a way.
Yeah. And I think it's really interesting because there's this idea of using a neural network to essentially like compress some sort of domain knowledge, and to be able to, kind of like the rise now of having these fine-tuned GPT type models, or like these kind of agents that would have specific compressed knowledge, and then being able to connect them like through agents. I think it opens up like possibilities, right? And then you would have something, for example, in the case of architecture, where you could have like the International Building Code compressed into one of these models, and then use that as a way to bring that data into your architecture design, and then have it like check some of these things. So I think that possibility is really interesting, and then it's kind of curious to see where that would develop as an industry for architecture. And then I guess like a question that comes out of that is like your work on like carbon, um, or embodied carbon, and like using these models to be able to track that. It's kind of interesting. I haven't seen that being deployed before in that sense, or using generative models in that. Can you talk a little bit more about that, and where you kind of like see the potential of this?
Um, yeah, first, like, okay, we don't really have access to a lot of data as architects.
Yeah.
So generating data in suitable format, or even already like in suitable perspectives. So it's like actually of like great value. Um, Also like for a lot of places you don't have really like access itself, like literary access. So it makes very much sense to go then into kind of generating data. And of course, like you can quite a lot of information derive from those like generated data. Um, with the carbon emission, embodied carbon, I mean, so it's kind of like we was interested to that project, kind of stock taking of like existing forms of constructions, or like is there maybe kind of forms of construction, forms of materials, or when you begin to cross-link that, already like, which would be less carbon intensive in a way when you see places. But also how those distribute is actually, it's interesting when you see on a map that actually places with high intense, low intense can be quite proximate. No? Usually we talk about difference based on nations or something. Like it's very broad, very large scale, how we actually classify in a way like carbon emissions or footprints. No? And those kind of going at the scale of placemaking and scaling up also the data helps you in a way now to understand actually planet actually at a local scale, or those kind of emissions or forms of construction begin to leverage with each other. So that's of course like any output of those models is probabilistic, was not like it's some statistic. So there's of course like a high amount of vagueness. So like it can show a tendency. It will never like have like really absolute numbers for that. So there's maybe like with text data, or like I know already like the new models, or also like the anthropic models, they're getting very good into actually precision or mathematical precision already. But again, there's a difference between like like image data and text data. Or like image like takes so much more resources, so this will take still like a while to you get the really like reliable output. So and yeah, and I generally like, for me it was more like a case study how you can really like go beyond the speculation, or not try to contribute like on a field where like kind of can you actually quantitatively like, or like get an output from those? Can you get actually like a scale or mapping which does not yet exist with a common database? And yeah, like I can like only like suggest or motivate people like really to use that for all synthetic data, like for in a way scaling up in a way just input in any form. It's very actually quite straightforward or quite simple actually to build up in a way data sets, which again you can use in a way to train like now certain behaviors, certain, or have certain like synthesis or certain conclusions on that. And I don't mind yet that is like it's not very precise. It's more like gives you direction to go. Like I think the basic direction from such outputs already going the right way. So you make like anyhow like a step forward with a research. So I think this is important. Yeah.
So the main I think what's interesting though, it's also that you were able to use some open source models from, well, the segment anything model that from Meta, that's kind of become kind of like a foundation model for segmentation, right? And it's pretty, it's decent. And like what you mentioned is kind of like this approximation of being able to use that to capture some trend, and then you can probably expand that like how you did, where you can take various cities or sampled cities around the world using, I don't know, Google Maps or something, like some platform that lets you get actual real images, and then deploy this if you have like a fine-tuned segmentation model like that, and be able to track all those materials at scale. And what do you think of the possibilities maybe of like urban design, or how this might help, I don't know, city planners or authorities, for example, like the Energy Department of the United States, and how they can be able to use that to develop policies or for carbon neutral buildings? I don't know if that's something that you thought about, but I'm curious your thoughts.
Yeah, it's very nonlinear, very much like embedded. For example, like using concrete, it's not always there's a polemic against concrete, but if the concrete is recycled, then actually not. No? So it's very much depends also on the form of construction on a like kind of other kind of features within that images. So for that project, for example, what I did is was not only using the segmentation with segment anything or ground Dino or YOLO models, which are, by the way, also the data, what they are pre-trained on is predominantly in like human perspective or like common kind of photography. So it means, for example, you can't really recognize a building because you never have like a full building on a photo, or people don't tag a building. They tag in front of a building. No? So it's actually, you need, for example, like looking at a building, you need like kind of reverse engineering. You have to go more over the assembly by, for example, tagging or like looking for amount of windows or so. Similar with the materials. But what I then did actually, looking also compressing certain construction types, or like taking samples from data set for, let's say, concrete building. And now in a way, like also cross-checking in a way that you have like what's similarity between a certain form of construction. So in that way, like you can, cause like that image is like is at first like only the facade. But when you're, as an architect, look at a facade, you can very clearly say, like, is it actually with a high kind of, not like a certainty, you can tell what's the method of the entire building by listening away layout, or like look in a way more like really on that the depth, or like the full volumetric kind of embodiment, not just like a material use on a facade. So, and this was then actually important, like by cross-linking now several methods, and actually doing this consciously, or like very much operating as an architect here, as an expert. So it's not only the capacity to automate and like, wow, go through like 100,000 of images, but actually it's only possible through kind of cross-links, which like standard, or in that kind of standard pre-trained models, like not any researcher would think of, because like it's just about like getting first the level of standard object or common object recognitions. So this kind of measures, or like kind of objectives, which you would have or architects have, of course, are not like common objectives. So they will never appear in the kind of like pre-training of those models. And I think here comes the relevance in as an architect. At first, as you begin to combine a set of models, and how you correlate now actually meaning within the data. And here's of course also like something that like you could now, like in terms of coming back to the policy making, where you can actually more like actually, I don't think that you should at the end have come up with a metrics. They say what building is bad or good, or like that you just use in a way the result of like what is the let's say the embodied carbon in one building. You say one is more intense, one less. But I think more is this kind of like cross-linking, this kind of like setting up protocols which could lead to much more specific decisions in terms of like assessing like really the life cycle of a building. Like you can really now, or you can use such now also, that how you assess actually existing building stock, what building is actually worth to renovate, or what would be actually the priority for renovating.
Yeah.
So we should actually in 10 years, or I don't know, like a very unrealistic time frame, we would need to in a way refurbish, renovate the entire building stock, which is impossible. So how you would actually build up decisions for let's say like simply the government, like what, or city councils, what kind of school building I would need to refurbish first, for example. So I think there, like such kind of beginning like to measures building actually correlations in itself, and building away this as a bot out or something. that in a way I think would be much more contribution in a kind of like world of policy making as a kind of decision making tool in a way. I would see it more like that. Yeah.
Yeah. Yeah, and that's really interesting because that captures like some let's say unseen data that we might not have access to from like an urban design or planning perspective. Then these kind of like AI models kind of like let us open up into that area in some way, right? That allows you to capture some sort of metrics or some statistics about that, which I think is really fascinating. And if we can kind of like keep pushing like at that level where we using these models to unlock new data or new information about the built environment. Um, and you said it like in the paper that according to the UN, I think it's UN Habitat that we gotta find ways to reduce the carbon emissions, but what should be a double building stock to 10% of today's emissions. So combined, like the increased production of buildings, which would be 20-fold, like how do we do that while reducing carbon current emissions? So I think that's like really important, especially at the trends that we're going. Um, and maybe like this is kind of like one of those approaches that might help us realize maybe what is current, like that current data in the physical environment.
Yeah, I mean, data is like also it's very much narrative related, no? Like
Yeah.
it's very political because or culturally embedded. Like from any like is it square meter or is like weight, like any kind of measure is also very much first like agreed on that there's a certain relevance to that. So here you come also in when this data becomes more complex and like life cycle assessment certainly is, which is also about the use of buildings or like where it's how you measure even the use, how you measure actually what kind of building part contributes or like is more relevant for use. Or you see like very quickly it's highly nonlinear and so on. But I think here you as a designer and like with the capacity to be creative, you begin to interlock now with these models that you actually make decisions. What is actually relevant data? So for
Mhm.
anything, what those models contextual build up and offer you in terms of like enabling you to see similarities or see some kind of rhythm or something, also to offering you over like a now set of generated content. Um, to see something relevant or see something, like always like reappearing or whatever it is,
Mhm.
you begin actually to speculate on this output. Right? That's the same way you can say like, hey, Midjourney is not creative. It's like you who begin not only to prompt, but to make the selection on that generated images. So when you further like map this onto how you behave with data or creating data or like, then it's of course like is very much what you inject is actually uh, your kind of projection of a future. So, and there's, I think, a way which we don't use yet that we not even like see anymore, just pure the build form as a way like to drive in a way like the build environment, but it's actually what would be actually the form of a metrics, the form of like in a way changing regulations or like of course like today like so many problems actually related to that that actually building codes are very frozen or like very much like fixed, which doesn't allow in a way innovations. So we need anyhow like a lot of architects doing this, that you go into kind of like redesign of building codes. The zoning laws in America like is a great example, no? Where like
Mhm.
everything is like in suburban zones in a way regulated. So going here actually and now like designing itself like what would be data and injecting is actually into like the base models.
Mhm.
That would be actually is one form also of kind of like activism or like kind of critical design that you can begin to use. No? So and so I'm trying also like it's clear that kind of describing the building itself is in a way like automated now, like with those kind of scale of those models. So we need anyhow to find like new ways of or different ways of being relevant or like operating built environment. And working on that, creating data could be then in a way like one way. And I don't think that this is dry at all, or like this is not, data is not neutral. It's very much designed and like very speculative item in a way. So it's very familiar actually to architects. So how you always like have in a way make decisions on buildings, or how a discussion about like, hey, why building is good or so on, like however you already did it. So yeah.
Yeah, that's really interesting. And I think the point that you made about metrics is also interesting, because if you look at like energy codes and stuff like that, there's like a few ways that you can meet kind of like the government, or like if you use ASHRAE in the United States, or these kind of like checklists that you would get like for a performance of a building. You can also do like model like energy simulations, which should ideally give you more accurate results, especially for like a more tailored custom design building. And I think it's kind of curious to see where that might help with AI, or is there like a way to compress that knowledge in some way that can be used to essentially check how your building's doing better, how cities are doing better in a much faster way. But the issue with metrics is kind of curious, because then you have to get people to agree, and there has to be like benchmarks in some way to get the performance out of it. So it becomes also like a very political issue. And I'm wondering like if it's something that architects should focus on, or is that like leave it up to like the policymakers in some way?
I know, like that's I think you bring up a great example. Like usually you would take on the assumption of based on kind of mathematical equations, for example, that
Yeah.
you use actually much less surface area. You build in cubic forms, but use windows and all those kind of strategies which we use actually for saving, or which are like inscribed in regulations on buildings today. When I have a more smarter design, I mean, a forest doesn't look like a cube. So there's something in the performance of ecological systems which outsmarts in a way like a cube. So okay, it's like very, very picturesque, this kind of metaphor. But when I come up now as a designer to make a more intelligent building, which is not based on a very simple scheme, then of course I need to prove that. And here, like already like rendering or simulating your building with synthetic data in realistic environment gives you actually that data.
Yeah.
It gives you actually, it's like a benchmark in itself. So this models become like as a digital twin of a digital world or world making, offer you like now environment also like compressing the time of like the whole life cycle with that build. I also noticed that now when I work with students, what I notice, because you can so quickly now design buildings, that actually design itself becomes boring. And now you begin to think about the age of buildings. Now we always we get stuck as architects that we just talk about how you would build a building. But then just like it actually starts off like you should think what happens in that space, what happens like, yeah, like not only like how you erect a building with a certain material, but how does this material actually age?
Yeah.
When I should replace it, how does it regrow and all that things. So and this now, because like we're on a new level of complexity or speed with designing, you see that more and more actually begin to think that way, that you think actually much more far reaching because you have the capacity to that. So, and here's also like just like articulating this and again in serious manner would very much help actually to move anyhow like decision making forward. I think when you offer like a serious set of data and conclusions, and not only like the building or representation of the building itself. I think everyone in a realm of decision making or more at higher levels would be very glad actually to get such offers or get like new scientific insights. No, we see as architects, we see as always like bounded by regulations, and as always in a very abstract manner. But also maybe because we didn't have the capacity of like really outreach also, no? Or like really connecting in better ways to different fields, or like like urban studies and policy making and so on. But I think now we have this. No, we have that. Well, very simple, like already with the chatbots, you can very quickly change like a text into a different vocabulary, which is like more suitable for a different field. And so on. So like, and I think this really like enlarges like the capacity what you can do as architect. And I think everyone would be happy if you like can now offer more serious like design solutions, really like contributing food design actually to all those larger problems.
Yeah, and I think what's interesting now is like recent additions to like the building code. Like they're now incorporating for example, like timber buildings, right? Like that's now become something that is accessible in the building code itself. So you now have like prescriptive rules of what you can do with timber or construction, which I think is probably also aided in the sense by simulation or these sort of digital tools to be able to test these things. So I think that's also like another exciting like area that opens up if you can now incorporate these models into it. Daniel, so we're reaching here like the hour. So I just wanted to end with a final question, which is what advice do you have to architecture students or your young practitioners that are I guess like seeing all these tools and like the rise of AI and they're living this moment. What do you recommend, or what advice do you give them? And then we can close with that.
Yeah, fully dive in. I mean, it will always be clear that it's very easy to get scared by seeing the performance, or every year you get into a completely new scale and so on. But what always is missing is creativity. You will never bet creativity. And it needs always also, so those models, however smart they are, it needs always someone like working with those models. But also any form of automation never led really to automation, but just like on a new kind of a scale. I mean, never work never got less and so on. So, and here like I can just recommend like fully embracing that, working with those models. If you have to write an essay or like whatever kind of as a form it is, because it makes you quicker think. It makes you quicker to produce something, but also on a just different scale of sensibility and creativity. So you learn with those models to become actually more the same as those models, like in a way, raise the level. They raise actually the level of your own kind of creativity. And as I see the most like exciting, like always, like also doing or like pushing very much that work in studio. And when you get relieved a bit like from kind of stress or this kind of dark side of what AI means, uh, it's actually very exciting. It's like because yeah, you on a very different sensibility and creativity you work, and you very quickly realize how quick actually you could change the way how you would actually build, because you can with a higher sensibility and much more local context work. Uh, those will not be high technological, those results which you come up with. They will be mostly like in a very alternative, very specific way they will work. And so I think there's also more where the future goes, that everything would be more like very, very custom, very particular to a certain set of, or like, yeah, a certain context would be developed, or you would be able to build, you know? And yeah, that's from my side. Yeah.
Okay,
Yeah.
awesome. So cool. Daniel, thank you so much. I'm gonna add the links to your research papers here. I'll post them in the YouTube link. But thank you so much for this. This was really interesting, and I do think that some of the work or like the research that you're doing now kind of like opens up this area of creativity for architects or designers in a way that they can see how connecting these models uh can lead to or propose like new solutions or maybe things that we didn't even think of doing before. So I think that's really insightful of you. And again, thank you again for doing this. Really appreciate it. And yeah, I'll close it over here. So thank you everybody for joining. And we'll be doing more interviews like this coming up. And stay tuned. So Daniel, thank you so much. Have a good rest of your weekend, and see you then.
Thank you for the invitation. Yeah, it was a nice discussion. Thank you. Thank you for everything.
Thank you. All right.